Week 5 lesson number 2 proves theorems on secants, tangents, and segments. The first theorem is radius tangent theorem. States that if a line is tangent to a circle, then it is perpendicular to the radius at its point of tangency. In the figure, we have a point, which is point P, and this is the center of this circle. So the circle is named as circle T, having a line that touches the circle at point B. So this line is what is your tangent, whose name is line KR. Again, sa figure na to, line KR is our tangent to circle T at point D. And segment TB is our radius of this circle. Therefore, if we have a line tangent to a circle at this point of tangency, it means the radius intersecting the tangent at point of tangency is perpendicular to this tangent line. So therefore, TB or segment TB is perpendicular to KR at point B. And point B is our point of tangency. Now for the converse of this theorem, radius tangent theorem, it states that if a line is perpendicular to a radius at its point of tangency on the circle, then it is tangent to the circle. Next theorem, we have the two tangent external point theorem, which states that if two tangents are drawn to a circle from an external point, then we consider the following possibilities. The first one is the tangent segments are congruent, and the second possibility is the line joining the external point and the center bisects the angle formed by the two tangents. To explain this further, let us again draw a circle whose point is at point C. So this circle is named as circle C. And we consider a point outside the circle, which is the external point W. And in this point, we draw a tangent at this point. And we name that point of tangency as point X. And on the same external point W, we draw another tangent which is also touching the same circle at this point. And we name that as point Y. So kung napansin natin, dalawang tangent sa iisang circle, base sa unang possibility, yung W, yung segment WY ay equal sa segment WX. Okay, so therefore, if they have equal length, it means that segment WX is congruent to segment WY. Halimbawa, kung ito ay 10, kung ito ay may length na 10, itong segment na to ay meron ding length na 10. Okay? Next. Now, suppose the angle formed by these two tangent lines has a measure of 60 degrees. Okay? Now, if we connect a segment from external point W to the center of the circle C, this segment will divide angle W into two equal parts. So if this angle is 60 degrees, each of these parts will measure 30 degrees. Okay? Now, these two equal parts are two angles, and one of each has its name. So that is angle YWC or and XWC. Now, if each part is 30 degrees, therefore, angle XWC is congruent to YWC. Okay. So, next, next theorem, we call it tangent secant on the circle intercepted arc theorem, which states that the measure of angles formed by the intersection of a tangent and the secant on the circle is half the measure of its intercepted arc. Now, suppose we have another circle whose center is at point C. So this circle is named as circle C. With this figure, we draw a tangent at this point. And that point of tangency is point W. Now, this tangent is named as line XY. And along this line, we draw another line passing through these points. One point on circle C and the point of tangency. And this yellow line is your secant, whose name is line BW. So in this circle, secant line, whose name is line BW, intersects tangent line XY at point W. So kapag ganun ang nangyari, itong dalawang lines na to ay may nabuong angle. And that angle is named as angle BWX. Okay? So if we are to determine the measure of this angle formed by secant and tangent, whose vertex is on circle C, the measure of that angle, BWX, is equal to 1/2 the measure of its intercepted arc, BW. Halimbawa, may sukat tayo ng arc BW which is 160 degrees. Using this formula, we can therefore determine the measure of this angle as half of 160 degrees, and that is 80 degrees. Next theorem. This one is angle formed by two tangents theorem. And in this theorem, the measure of an angle formed by intersection of two tangents on the exterior of the circle is equal to half the difference of the measures of the major arc and minor arc. So if we have another circle whose center is at point O, so this is circle O, and we consider an external point, or we consider a point which is the exterior of the circle, and we name this point as point X. Then we draw a tangent line from point X, and the point of tangency is point G. And we draw another tangent line to the same circle O, going this way from point X. This one. Or should I? Oh yes, another tangent. Yeah. And the point of tangency is at point H. So with these two tangents, there is an angle formed whose vertex is at point X. So this is angle X. Now, to get the measure of angle X, based on the theorem, okay, so if ray XH and ray XG are tangents to circle O, then, okay, to find the measure of the angle formed by these two tangents, that is the measure of angle X is equal to 1/2 the measure of the major arc GFH minus the measure of minor arc GH. Okay. Now suppose we consider its intersected arcs with their measures. For the major arc GFH, suppose it is 260 degrees and its minor, and the minor arc GH is say 100. Now to get the measure of angle X, we use this formula. So that is 260 minus 100. So taking the difference of these two, that is 160, and get half of 160, that will give you 80 degrees, which is actually the measure of angle H. Next, for our next theorem, angles formed by tangent secant exterior point theorem. This theorem states that the measure of an angle formed by intersection of a secant and a tangent on the exterior of the circle is half the difference of the measures of their intercepted arcs. Now again, we consider a circle whose center is at point O and an exterior point named as point X. So from this point, we draw one secant and one tangent to circle O. So this one is a secant because it cuts the circle at these 2 points. Okay, and these 2 points are H and L. And then we draw a tangent. From point X, it touches the circle at this point, whose name is point G. Now, if in circle O, ray XG is a tangent and ray XF, this one, is a secant, intersecting at X, then the measure of this angle, X, equals 1/2 the measure of arc FG minus the measure of arc GH. For example, we have the measure of arc FG, which is 170 degrees, and the measure of arc GH is 80 degrees. To compute for the measure of angle X, using this formula, we have 170 minus 80, that is 90 degrees, and take half of 90 degrees, that will give us 45 degrees. Therefore, the measure of angle X is 45 degrees. So that is your angle formed by tangent secant exterior point theorem. Next, Next theorem is angles formed by 2 secants interior point theorem, which states that the measure of an angle formed by 2 secants intersecting in the interior of the circle is equal to half the sum of the measures of the arc intercepted by the angle and the angle vertical to it. Again, we have a circle, and with this geometric figure, we draw a secant and another one. First, for the first secant, we name this as line fx, and another secant, we name this as line gy. Now, you will notice that these 2 secants intersect at point H, which is the interior of the circle. And you also notice that these 2 intersecting secants form a pair of non-adjacent angles that are called vertical angle. And these vertical angles intercept uh, 2 arcs. And these are arc Fy and arc Gx. So, yeah. Again, line Fx and line Gy are the 2 secants intersecting in the interior of the circle at point H, forming forming vertical angles. And these are angle GHX and angle FHY. Now, to get the measure of each of these 2 angles, we have this formula. The measure of GHX equals the measure of FHY is equal to 1/2 the measure of arc Fy plus the measure of arc GX. For example, if your arc Fy is 50 degrees and your arc Gx is 70 degrees, based on the formula, we get the sum of these two. So that is 50 plus 70. And we know that is 120, and we take half of 120, that will give us 60 degrees. Therefore, these 2 angles right here indicated by question marks are actually both 60 degrees. Next, probably this is the last theorem, and this is angles formed by 2 secants exterior point theorem, which states that the measure of an angle formed by 2 secants intersecting at the exterior of the circle is equal to half the difference of the major and the minor arc, or the bigger arc and the minor arc, or the smaller arc. Okay. Again, let us consider a circle. So this is circle O. Then external point X, and we draw 2 secants. One is passing through point Z and point L. And another secant from the same external point X going this way and cuts the circle at these 2 points, Y and K. So from the figure, ray XL and ray XK, so ray XL is actually this one, and ray XK is this one. And they are both secants intersecting the exterior of a circle at point X. And because of that, there is an angle formed, and that is your angle X. Now, to get the measure of that angle, we have this formula. The measure of angle X is equal to 1/2 the measure of arc LK minus the measure of arc ZY. Now suppose this arc is 130 degrees, arc LK is 130 degrees, and the arc ZY measures 50 degrees. Now to compute for the measure of this angle, taking the formula, so we get the sum of these two given measures. So 130 plus 50 is actually 180. And I mean, wait, okay, it should be the difference, not the sum. So 130 degrees minus 50 degrees, that is actually 80 degrees. Then take half of 80 degrees, that is 40 degrees. And that is the measure of angle X.